All right, good stuff. Hi, everybody. Good afternoon, good evening. Thank you so much for having me. As was just well explained, my name is Josh Long. I work on the Spring team. I'm a Java champion, a Spring developer advocate, and a Kotlin Google developer expert in no particular order. I'm also at your service, so should you have questions, when intellectually have questions, don't hesitate to reach out to me. There's my Twitter. You can find me on Twitter. Send me direct messages. I'm very happy to engage, always happy to carry the conversation forward beyond the oh-so-finite time that we have before us in this brief slot today. What is it, 30 minutes or so? That's just enough time to get warmed up, really. So don't hesitate, my friends. I'm happy to answer questions. Ditto for email. I don't love email, but hey, I'll take what I can get, right? Email's okay. As was just well explained, I've been on the Spring team for now plus 10 plus years. I do training videos. I've got a book called Cloud Native Java. I've got a podcast called the Bootiful Podcast. I have This Week in Spring. It's a blog every Tuesday. That's today, where I round up all the news that's fit to reprint in the Spring ecosystem for the last 10 years. And of course, a screencast series where I talk about different corners of the Spring ecosystem, all the different bits of arcana. And finally, I have a book called Reactive Spring. And really, if you want more on what we're going to talk about here, don't hesitate to reach out to me. But if that still doesn't get you to where you want to go, maybe you like the book. Who knows? Doesn't matter. Either way, what we're going to talk about today, my friends, is not reactive programming in general, but in particular, an application of it through RSocket. And so in order to have this conversation, in order to be able to do a good job there, I think it's very important that we just start with some software and kind of see what we're trying to do here. So what we're going to do is we're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. But if you haven't already been there, then you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a brand new application using the latest and greatest defaults. Now, granted, there are a lot of reasons why we might want to use 2.40 RC1, not least of which is that we have this incredibly good support now for GraalVM, the native image support in GraalVM. And while I don't want to spend a whole bunch of time, what precious little time I've got, spinning up a demo and then cross-compiling it for you, the results when you use GraalVM are these applications that take up very little memory, and so you can get them to start in a tenth of a second and so on. That particular example that I just showed you includes a SQL database. I'm not a client connecting to a database. It includes the database. It embeds H2. So it's including the database. It has a SQL data access layer and the web server, and it's taking the creakingly long time of 0.129 seconds. So I hope you'll check that out. But most of what we're going to look at today, indeed all of it, will work just fine in Spring Boot 3x, which is the current GA generation. And so that's fine. What we're going to do is we're going to build an application using the current defaults. We're going to name this, imaginatively enough, service. And then we need to pick a version of the JVM that we want to use. Now, friends, before you've got a few selections. You've got a few radio dials that you can select, which imply choice. It looks like you've got 3 choices, when in reality, you only have 2. Okay, now before you can see there's Java 15, which is the current supported version of Java, Java 11, the current long-term supported version of Java, and then Java 8, which is a non-choice. That's not just a bread, friends. That's a choice that you could make, but that you shouldn't. You should never, ever make that choice. That's a terrible version of Java on which to build anything today. It's technically inferior, slower, less syntax, less security, less robustness, less everything, but it's also morally inferior. How do you think your kids are going to feel when they find out that you're using Java 8 in production? I don't think you're going to like that conversation, friends. It's not a good one. Don't do it. Be better. Be the person you want to see. Use something more civil. Now, we're going to build an application, and we're going to take advantage of RSocket, of course. That's the name of the talk, after all. We're going to take advantage of Lombok and perhaps Spring Security, and I think that ought to do. Okay, so we're going to hit generate. And first things first, when we contextualize reactive programming, when we talk about reactive programming in the ecosystem, in the Spring ecosystem, really we're talking about a conglomeration of different sort of integrations and different projects, all of which build upon the Reactor project. Now, Reactor, in turn, builds upon the Reactive Stream specification. So if you're trying to build reactive applications, then it helps you in the Spring ecosystem to understand how Reactor works. Now, granted, if you've come from something like Akka Streams, or if you've come from something like RxJava, you'll feel right at home. Truly, these things are designed in some ways, I think, to mirror each other, right? They have the same ideas, the same goals. Now, obviously, they go about them in different ways, and that's okay. And even better, you can actually, these things are not necessarily exclusive, right? They can be orthogonal. So one of these things can work with the other. For example, you can easily have Akka streams be used to do some calculation out in an Akka actor system while you return a publisher that gets returned from your Spring WebFlux endpoint. And so I love that composition. I love the implication that I can write software using these reactive types, and I get ease of composition. I get ease of understanding because that's API. And it also makes it much easier to deal with the inherent volatility of building distributed systems. So let's suppose I had two fluxes, okay? A flux is a reactive string that builds upon the publisher type. It's a type that produces 0 to n values, where n is potentially unlimited. Let's suppose I wanted to call a downstream microservice, and I wanted to get a response in a guaranteed amount of time. I could say, okay, let's say call equals this, and I'll leave it to your imagination here what it looks like to use HTTP, but I could say call dot, on error resume, and then when there's an error, I can actually determine how to degrade gracefully, very good in microservice environment. Or I could say call dot retry, and that way I can retry, and maybe retry 10 times, and maybe retry, when, back off, there we go, retry, come on, do the thing. There you go. Okay, so you've got all these utility methods here, 10, duration of seconds, 10. Okay, so I can retry the call if I want to in a certain context, or I can do timeout, all these kinds of things. All these are very useful, but consider what I want to do here. I want to make sure that I get a response within a certain amount of time. Here, I could make a bunch of calls at the same time to different discrete instances of a particular service, and whichever one produces the response fastest, I keep that. This is a very common pattern in a microservices context. It's called hedging, right? Like hedging your bet, put all your eggs in one basket, don't put all your money in one stock option, etc. Ditto here, right? So instead of calling one service and hoping the load balancer will route you to an instance that's live, you take no chances by instead launching multiple instances, multiple requests, and whichever one responds fastest, you keep and you apply back pressure to the other ones. Well, this is a hard thing to do without reactive APIs, but it's trivial to express this kind of logic using these operators. And so it really does behoove us to learn these operators that underpin all of what we're doing in the Spring ecosystem. They're from Reactor, right? So this kind of stuff is natural in a microservices context. Another thing that I love about this is I can support easy scatter-gather kinds of service orchestration and composition. Let's suppose I had a type customer, right? And I had a type order, right? And so I'm just creating different types of data here. Class customer order, okay? So string ID, private string, there we go. And then this is going to be private string customer ID, and this one will be private string, right, ID. So now I've got two different types, and these types I want to get from different microservices, one from the customer microservice, the other from the order microservice, and I want to compose these in this kind of scatter-gather style. So what I'm going to do is I'm going to create a reactive stream, and I'll, let's suppose I have a stream of orders from some source, right? We'll worry about that later. And I have a stream of customers from some other place, and I want to visit each customer, and then for each customer, get all the orders from them, right? So imagine I have some way of getting customers for a particular, getting orders rather for a particular customer. So I can say publisher of Flux order, get orders for string customer ID, right? So all I'm doing is I'm building up a pipeline here. I want to build up a pipeline, and imagine I've got some sort of CRM service or something that's allowing me to talk to these things. So I want to say, okay, for each customer, map each one, or flat map each one rather, into a C, and from there, I'm going to use the zip operation to take two different streams, the first of which will contain just the customer itself, right, C, and the second of which will contain the orders, right, the orders for that customer. So I'll say get orders for customer. Oh yeah, this is static, of course. Get orders for customer. And then I say c.id, and what that gives me, friends, is a stream of tuple of customer. Well, of course, at this point, it's trivial for me to map over it and aggregate that into something more meaningful. So .map tuple .get t1, and there's my customer. And I can even say, give me the orders, and then collect that as a list, right? So there we go, and that gives me tuple.t2, right? Tuple.get t2. Oh, here we go. Tuple.get t2, and you can see that's a what is this? Get orders, right? I want to collect as list. Why does that not work? Collect as list. Yeah, there you go. So, oh yeah, here we go. This is the issue. Mono of list of that. Okay. Good. Java util list, please. Okay, so I'm just aggregating these types, and obviously there's a bit of, there we go. Here, just do this. I'll just cheat. Use the IDE to help you out of this in situations like this, friends. It's your only lifeline. Okay, so there's my stream, and now T2 is the list of orders. And so you can see how easy it would be to sort of just visit all of that, right? To take each one of those things and turn it into an aggregate type, right? So here for each customer and list of orders for that customer, I can do whatever I want to it, and I can create an aggregate type. So you can see Reactive APIs make it trivial for scattered gather service composition. So okay, so what am I getting at? Well, all of this is something I could have shown you when I was looking at HTTP. It's something I could have shown you when I looked at any other thing. But what has been missing sorely in the world is some way to do this over the network. And so for this, we are going to look at RSocket. Now, RSocket is well supported in the Spring ecosystem, and that owes in part because the Java client for RSocket, of which there are many clients, by the way. There's C++, Python, Go, JavaScript, etc. The Java client itself was written on top of Reactor. So the same Reactor you just looked at, the same one that made it easy for me to map over two different sources of data and aggregate them in a meaningful way, in a concurrent way, in just a couple of lines of code. The same one that you just saw me use to do patterns like hedging that make this kind of trivial sort of service orchestration composition fun and fast. That same Reactor library is what underpins the Java client for RSocket. So we are going to create an RSocket endpoint, and it's just going to return data. It's just going to return a greeting, okay? And this greeting, of course, is going to be a greetings response, and it's going to be a greetings response that we're going to request. So we'll say private string name, and given a name, we'll return a response or a message. Okay, so I'm creating these two different types. I'm going to send them over the wire, and what I want here is some way to have a network service that understands back pressure, that extends the concept of back pressure to the network. So that's RSocket. I want something that supports asynchronous communication as well. Obviously, those aren't necessarily implied, but this ticks that box. I want something that supports all the different message exchange patterns that I could want in an architecture, including fire and forget for things where you want to send something out, but it's not critical that you acknowledge the receipt of that thing. I want to support bidirectional communication. I want to support streaming of data in and streaming of data out. I want to send a single message in and get a response of streams out, etc. All these different message exchange patterns are not as easy as we'd like in other protocols. In HTTP, it's response. You can kind of fake it, but you're really not dealing with two equal nodes here. One side is the client, one is the service. You can do asynchronous kind of communication with WebSocket, but then you're kind of, what about headers? Like, how do you do out-of-band security? How do you propagate out-of-band information like a security token without headers, right? So these are things where it would just be nice if the protocols supported these use cases. I don't want to spend too long motivating RSocket itself, as really this is just a discussion of how it's used in the ecosystem. So I've got a service here, and this service is going to produce a response. Okay, so I'm going to say greet, and I'm going to create a request, and I want to return just a reactive stream. I'm just going to create a stream out of a stream, a new stream out of a stream, and that stream is going to return a greetings response. So I'll say a new greetings response. Hello, React. Well, actually, I'll give it a name. Request.getName at instant dot. Okay. Good. Come on now. Good. With that, now what I want to do is I want to make sure that I, first of all, I want to slow the results down, and I also want to limit them, right? I don't want to have too much, because if I did too many results or an infinite array, then it would very quickly scroll down the floor and out the door. So I want to stagger the results just a little bit here. I also want to limit how much I take, maybe just 100 records, okay? So here, nothing too RSocket-y about anything I've done. Here's where I'm going to actually connect my idea, my reactive idea, to the RSocket protocol. I'm going to create a controller in Spring. So I'll say class greeting controller, okay? And here, I'll say message mapping, greetings, and greeting response, right? And again, notice how I'm just returning publishers. I'm just dealing with data like I would anything else. Nothing particularly fancy here. Just injecting objects one into the other, just like I would in any other standard sort of use case. But the result is that I can write code that takes advantage of this RSocket protocol without having to worry too much about how I get that done. I don't know if you've ever used the low-level RSocket protocol, but this is significantly easier. So there's my basic controller. That's it. That's the extent of the work I'm going to have to do to create that RSocket endpoint in my Java code or any code really. I want to start up this service on port 8888, and then we're going to go ahead and oops, wrong one. I want to say RSocket server port is 8888. Okay. The other thing I need to do just proactively is I need to remove the security. You see, I don't want to not be able to get access to my data for the moment, so we'll comment out security. And with that, I'm just left with the RSocket support, really. Okay, so reload. Let's see if that goes. Run. Now, if this goes to plan, I want to be able to talk to it. And RSocket, there's a lot of different ways you can talk to an RSocket service. Obviously, you can use Java code, and we'll look at that opportunity just in a minute. But there's also something called RSC. RSC is the RSocket client, or it's a RSocket client. It's from my colleague Toshiaki Maki. He's over in Tokyo. He's the best, and he wrote this RSC client, which aims to be kind of like curl for RSocket. So you can say, I want to make a streaming request that describes the kind of interaction model, the exchange type. So is it fire and forget? Is it request to stream? Is it request response rather? Is it stream? Is it channel where it's bidirectional streaming? In this case, it's a single value in and multiple values out, so it's streaming. It's also, I'm sending the endpoint to TCP localhost 8888. The route is greetings, and the data that we're going to send is -d, like this. Right? I'm going to send some data in, and it'll get converted beforehand. Reactive sum it. Okay, and the name will be so. And so if I make that request, you can see I get a response almost immediately. And every second in perpetuity, it's not going to block. And that it's going to keep going. It'll send me 100 records, but it doesn't matter if it sends me 100 records. It can send me 1,000,000 records or 1,000,000,000 or whatever. And that's okay, because in between the raindrops, because we're using Reactive APIs on the wire, I'm not keeping a thread open in between those heartbeat events to send out that message. That thread is free to do work for something else in the system. So we get really good scalability here. But we've also taken these concept of back pressure. It's on the wire protocol itself now. So what I mean by that is if you have a reactive HTTP service and you have a regular client, because remember, HTTP doesn't speak back pressure, it doesn't have the concept of it. If you have an HTTP client and it disconnects, the absolute best that you can hope for is that the reactive service perceives that disconnect and cancels. And that's it. It applies cancel to all the other streams involved in producing the response, and that transitively applies back onward to the other streams involved in producing the response, and that's it. But something like session resumption and picking up the conversation later, that doesn't work, right? So here we have this actual opportunity to do things like session resumption. And you can see it's pretty easy to get a service up and running. Indeed, it's almost identical to what you would have done had you tried to do it with HTTP or something else. So now we've got our first client experience. Let's go build a Java one. Okay, so here we'll also use Spring Security. We're going to use Lombok. Okay, and we're going to use the RSocket support. All right, and we're going to hit generate and open this up in our IDE, UAO client.zip. And here we're going to act as an RSocket client to the service. Okay. Okay, so client application. And all I want to do here is I want to make sure that when I start up my application, I establish an RSocketRequester. And the RSocketRequester is one client you can use. There's also the new RSocket 1.1 experience, but this works perfectly fine for our purposes. And the idea is that we're creating the connection up front. That's the nice thing about RSocket, is that the services are, the connections are stateful. So once the two sockets connect, they stay connected for the life of the applications, barring any unforeseen circumstances. And if that should happen, then they can just reconnect, right? But they stay connected. So you don't have to target a particular request at a particular host and port as you might with an HTTP client. You're just assumed to be still ongoing connected to this. Obviously, the question of load balancing and all that comes up. You might want to point your RSocketRequester to the broker, to the hub, to an RSocket broker or hub, such as the one that we're building with the the rest of the Reactive Foundation ecosystem, right? So RSocketRequester, very convenient client. I want to now listen. I want to make a request of the service, right? So I'm going to create a bean that'll get involved when the application starts up, and I'll inject my RSocketRequester here. And all I'm trying to do is just to call that downstream service. So I'll say RSocketRequester route greetings, and I need the data, right? I need to send some data in as my request, right, to the parameter. So I need to do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So I'll go here and take my greetings response, my greetings request, and take it to my my client, paste it in there, and we can continue. So now the data I'm sending is a new greetings request, reactive summit, okay? And the response that I'm expecting is a greetings response.class, and I want to log out those results as so, like so. So system out print line. Okay, so good stuff. So there's my RSocket call. Let's go ahead and see if that works. So I was going to run this application. I was going to run the client, and I was going to see the results. And then I realized that this won't actually work because this is a client, and there's no reason for the port to continue. So I need to prop the JVM open, so it doesn't shut down. Because remember, my reactive code might run on a different thread, and that might not endure long enough, or the JVM might not endure long enough. So I'll just read standard in there, and then I'll run the client. And if everything goes to plan, we'll see our results. Look at that. Greeting response, right? So now we have a response, good stuff. That works, right? Obviously that works. That's a kind of an RPC kind of thing though. I'm saying call this endpoint, sending some data in, getting a response back. And one thing that people often ask about is, can I make that easier? Is it possible to make it easier to work with RPC kind of stuff, right? So there's actually a very nice little project that, if you don't mind my saying so, of course, if you indulge me a little, congratulatory pats on the back here. There's a project called Spring RetroSocket that I created after a conversation with my buddy Mario, and the project aims to provide a feign-like or a retrofit-like experience for RSocket. And so it's experimental, and it's definitely not GA. Okay, I just want to highlight that, but you can easily add it to your build thusly. So you take the repositories, copy and paste that, paste it in the manifest of your build, right? Your Maven build or a Gradle build or whatever. I'll add those here. And with that on the class path, then we can add the dependency proper, and that's just the one dependency for Spring RetroSocket. So you go over here, paste, whoops, and you need the particular version. And the version here will be 001 snapshot, okay? Good. So take that. Good, and then Maven reload, Command-Alt-L, and that should, if everything goes to plan, give us the dependencies we need, and we can activate that pretty trivially. We say @enable RSocket clients, and then we can just build an interface. So interface, greetings, client, okay? And here I'm going to return a publisher of greeting response, greet, given a greetings request, right? Looks familiar, looks more or less like the thing we had in the service. In fact, we could have probably even shared interfaces there. Not that this is the goal, but it's a thing that you could do now, right? So greetings. And with that, we can now create a second bean that'll listen for RetroSocket responses. So let's comment this out so we're not confused as to which one is delivering us the results. So application listener, application ready event, ready RetroSocket. And here we're going to use the greetings client that we just built. So return event, greetings client.greet, new greetings request, reactive summit part 2, right? There you go. And we're just going to subscribe to the response. So system out print line. Okay, so there's the updated code, if you can spell it correctly, that is. And we can run this. Let's see what we get. And there too, we have the results. So you can see it's trivial to create a thing that looks like an RPC client using RSocket because it supports RPC semantics if you want. But the thing is, it's not limited to that. And actually, one of the most interesting features to me about RSocket is the fact that it actually supports bidirectional communication. It's built into what I just showed you, RSocketRequester. We don't call it the RSocket client. If you wanted to do HTTP, you'd use the web client. But in the RSocket world, once two nodes are connected, either side can initiate the conversation at whatever point it wants. Either side can be a requester or a responder. Either side can be a client or a service, or both, right? These are not exclusive. So one of the things I want to do here is I want to actually have my client code, which is what we're editing right now, emit values that the service can use in service of the results that are being streamed back here in the first place. So I'm going to create an arbitrary kind of thing here, a health controller. And I say this is arbitrary because actually one of the nice things about RSocket is that it has it's been designed with operations in mind. So the people that built it so that it would have information about the state of the service, metadata that you could communicate that could be used to articulate whether a service was healthy or not, right? Things like that. And this is sort of akin to the actuator, the Spring Boot actuator. But remember, the Spring Boot actuator is a convention in the Spring Boot community. It's inspired by work that Google talked about in their white papers and so on. But it's really just a small, well, not small, but it's a minority of people compared to those who have built HTTP-based services that are using Spring Boot services. Is that fair to say? That's probably fair, right? So we want to make sure that as much as we love actuator, that it's not limited to just a convention. So it's really nice that RSocket has a metadata frame to communicate that kind of stuff. That said, that's not what we're going to do here. We're just going to create some sort of thing that the client will give to the service to indicate whether it should bother extending more data to the client, right? Some sort of has the client disconnected, or has the chat ended, or whatever, right? Some sort of feedback, or maybe this is a data about whether the client is still typing or still engaged in the game, and it's just constant heartbeat information going back to the service. I'm using health as a pretty trivial, easy to understand Boolean thing, right? It's either good or bad, right? So I'm going to return a stream of something called a client health state, and I'll do that just by returning. This is synthesized, of course. So I'll say new flux dot from stream.generate new supplier, new client health state, math.random is greater than 0.5. So it's going to be 50-50 chance. Well, not quite, but it'll be basically almost half chance that it'll work or not, right? So hopefully we'll get a few requests off before it then flips the circuit and it says it's not healthy. So I've got now a circuit. I got an endpoint on the client rather, that's going to advertise the health of each individual client, right? So now what I want to do is I want to go to my RSocketRequester, and I want to advertise that health controller. So in order to do that, I need to create a bean of type SocketAcceptor, okay? And I can do this, new SocketAcceptor, okay? Oops, no, not that. I want to do RSocket message handler dot responder, and I'm going to need the RSocket strategies. This is a thing that's very common in the Spring ecosystem. If you want to see how things are being configured automatically for you to advertise things like the health, the encoding and so on, then you're going to need to know about that. So client controller, health controller. Okay, there we go. So strategies and health controller, and voila. Okay. Now, this is a bean that I want to inject into my RSocketRequester. The very same thing I'm using as a client will now have a sort of an endpoint that's made available, right? So I'll configure, oh no, this is the event listener. I want that in the bean itself here. Let's see, where did I put my RSocketRequester? Down here. Okay, so I will say connector. Okay. Connect RSocket factory, RSocket connector. I think it's this. C.acceptor and socket acceptor. There we go. So now I'm advertising a client, and I want to use this. Now this is the client. So as soon as it connects, well, we're hoping that the client will then ask it a question. So that's what I'm going to do here. In the service, I have my controller, and in the controller handler method, I want to ask RSocket to give me a reference to the socket represented by the current client. So current client RSocket reference, right? It's an object I can use to talk to the RSocket client. And then so here I can actually say I want to call the health endpoint. And again, here too, I need to do something terrible. I need to copy and paste code. So I'll go get my client health object here. There it is, my client health state. Paste that in this client, and I'm going to use this now in the service. I'll say, okay, give me a stream of client health state dot class, and I don't want to keep all of them, obviously, because there's hopefully, if everything goes to plan, they'll all be healthy. I want to drop everything that's healthy. I only care about it not being healthy, right? So I'll say, okay, CHS is healthy. If it's not healthy, then I'm interested. So for most of the life of this pipeline, of this reactive stream here, it'll be empty. But when it's not empty, I need to know. That's exactly when I care, because as soon as it's not empty, I need to stop streaming the stream of responses. And this is a natural, nice thing, easy to express using these operators, right? So I'm going to say greet until this is not empty. Greet until that has emitted a value. Okay. So there's my my service. Let's go ahead and restart this. And once that's over here, restart this here. Hopefully we get a few of them, and then it'll stop abruptly, hopefully before the 10. There you go. So it got 3 of them done, and then it randomly got to not healthy, and it stopped the stream, right? So this kind of bidirectional communication, super useful, right? It's natural to do with these reactive APIs. So my friends, we've looked at a number of different things here. I don't know how much time we have on the clock left, by the way. Do I have another 5 minutes? I don't even know where we started or left off.
Yeah, we can do another 5 minutes.
Okay. And I hope you got something out of this so far. Since we do have another 5 minutes, I wanted to show you one more thing, which is how to lock down this application. So we've got this application talking to another side. We've shown you one side initiating the conversation with the other. We showed bidirectional communication. We showed you Spring Retro Socket and the RSocketRequester and RSC. All of this implies communication back and forth. Uh-oh. What is going on? Wow. I live in San Francisco, right by the Bay Bridge, and 3 cop cars just went they're still going blaring by towards the Embarcadero. I wonder what's going on. Anywho,
Packed full of excitement tonight.
Yeah, gee, I just can't catch a break. So okay, we've got a service, we've got a client. Let's go ahead and lock down our service now, because we've already established that we can talk to it, right? But we don't want to be. It shouldn't be that easy to talk to it, as we found out earlier on in this very presentation. A little extra security can be very helpful. So I'm going to introduce Spring Security. Now again, Spring Security is a technology that allows you to do 2 things: authentication and authorization. Authentication just answers the question, who is making the request? Is it Josh? Is it Jane? Who is making the request? Authorization answers the question, what privileges do they have within the system, right? So what rights does a client have within the system? Very much like if you let somebody into your house, certain rooms they can't go into. You know, you don't mind having your friends over, or your office mates over, pre-pandemic, of course, but your office colleagues and whatever, you don't mind having them over, but do you want them rifling around your underwear drawer? Probably not, right? There's limits. So authorization is all about what they can do once they're inside the system. So to set up authentication, I'm just going to take the lazy way out. I'm just going to set up an in-memory username and password database. Don't do that. It's a terrible idea. It's a really bad idea. But for a demo, it'll hopefully make clear what we're doing. And what you need to know is that Spring Security has a number of different integrations besides this incredibly trivial one that I'm going to show you. So you can talk to every IDP under the sun: OAuth, OIDC, SAML, PAM, Caberos, HTTP Basic, whatever, right? So here's my map reactive user detail service. And remember, this is one of those things I was talking about in the panel earlier, which is when you do security, when you do things like encoding and decoding of passwords, well, guess what? That's encryption. That's going to sit on your CPU, right? Obviously, you should be aware of that. And so this is one of those wonderful situations where doing the right thing is also the more performant things. You see, the right thing to do today for security, the security, common knowledge for security posture these days is to, as early as possible, exchange the user's long-term credentials, their username and password, for a short-term credential, like a token. So the earlier you can do that, and ideally on a separate node, which you can scale up independently, like an authorization server in OAuth, the sooner you can do that, the faster you are able to now bandy around those tokens in your system. So isn't that nice? Do the right thing. Don't do username and passwords. Do tokens, and do it with a separate authorization server. Okay, so that's authentication. Here's authorization, and again, I'm naming these beans as such, but there's no real reason to do that. You can name them whatever you want. Okay, so RSocket security. I'm going to say return RSocket security. build, and I'm going to lock down. I'm going to use an extension to the RSocket protocol to use simple authentication. So I'll say c dot. Actually, no, I want to do it. I want to accept the defaults. I just want to enable simple authentication. Now, who's that, and why is there noise? Okay, we're okay.
I think we're okay. I think someone just clicked off mute.
We got Zoom bomb PTSD. Okay. All right. So I could also enable JWT if I had actually wanted to set up the tokens and all that stuff. But there you go. That's my basic security config. I have one more thing I want to do though, which is I want to take advantage of that incoming user. So I want to say to the framework, please give me a reference to the current authenticated principal. That way, when I make the request, or when the client makes a request, I can actually look at the incoming encrypted, encoded username and go, okay, this is a greeting for that user as opposed to the greetings request in the payload. So I'm going to rewrite this code a little bit here, copy and paste that. And here, I'm still going to keep this old method, right? This is the old one. But here, I'm going to get rid of the greetings request that no longer applies here. So when somebody calls this endpoint, we're not expecting them to send a request. What we're going to do is we're going to take the current authenticated user and then delegate to the original method. So return this return authenticated user dot map ud to ud.get username, and then I'm going to map that user to a new greetings request user. I'm going to map that to a call to the original thing. So I'll say this dot greet, and here I'm going to pass in the RSocketRequester, right? So current RSocket client and the current greetings request G. Okay, so that's my new updated pipeline. I'm taking advantage of the fact that my system knows about a current authenticated user. The only thing is, this isn't going to happen by default. You have to teach Spring Security to know about this annotation. So that's pretty trivial. We can install a filter. And so RSocket has a filter model in Spring that you can use as well. And it's a RSocket strategies customizer. Okay, return new. Oh, sorry, no, it's not. That's not. It's not. It's a RSocket message handler. Okay. var RMH equals. What am I thinking of? var RMH new RSocket. There we go. Okay. RMH.get, add this new simple new arguments. There you go. And then RMH.set RSocket strategies, and we put this RSocket strategies here. Strategies. Okay. Pass that there. Pass this there. RMH. Good. So there's my RSocket message handler. That's going to configure the Spring Security bits on this side. I need to run this, and then on the client side, I am going to now connect. Now, of course, again, here I'll just use a username and password in memory. Terrible idea. Don't ever do it. But the way that communication is done in RSocket is through headers. Basically, they're called metadata in the RSocket world, and they're not key value as you might expect from Kafka or RabbitMQ or HTTP, but they're instead MIME type, content type to value, which is fine, right? So we're going to say MIME type, equals MIME type utils dot parse MIME type, well-known MIME type dot authorization. Okay, message RSocket authentication. And we're going to create, that's the key, and then the credential that I'm going to send across the wire is username and password metadata. So I'll say this, new username. Now, obviously, this is just an in-memory username and password. Terrible idea, like I said. But what I'm doing is I'm creating these as class variables to demonstrate something kind of interesting here. Remember what I said earlier. You can connect. You connect at startup time when the application starts up. So you can authenticate at two different points, either when the application first starts up, as I am here, or per request, right? And that's actually, is it the other way around? I think it's the other way around, yeah. And that's actually very convenient because, you know, if you have a socket that's being shared for everything in the service, if it's like a batch job, then you don't need to re-authenticate on every single request. On the other hand, if you do have a, you know, multi-tenant kind of thing where you have each user having their own connection and their own credentials, then of course you want to send that along there. So here is my, oh here, yeah, right here. I say metadata, same idea, right? Same thing, but again, backwards. Okay, so now let's run this application, and if everything goes to plan, it won't say, even though I'm sending Reactive Summit, remember, we've written the code on the server to ignore that. Oh, did I not? No encoder. Ah, that's the other thing, it's an extension. You need to configure an encoder, and I just about did this before on the other one, and I forgot, okay? Return new, so this kind of encoding, this mechanism for propagating simple authentication headers, that's not built in by default. It's an extension. So you have to tell Spring Security to know about that and to look for it and to encode it. Once that's done though, well, you know, you're ready to go. So here we go. Let's restart the client. And there you go. It says, hello, J Long, not Reactive Summit. All right, my friends, I hope you got something out of this. Obviously, we've just begun to scratch the surface. There's a lot more we could have talked about had we more time and were things just a little bit less crazy in the world, but things are going to be okay, my friends. We have just begun to scratch the surface. There's a lot of really interesting stuff that we didn't get a chance to look at, including the use for Spring integration and RSocket, and including the broker, the RSocket broker, you know, which has taken on a lot of different forms and been the benefit of a lot of different contributions from a lot of different organizations. And I think really represents a great, you know, win for the community, for the ecosystem. I love the collaboration that's happening here. RSocket is being used, as you may no doubt know, by a number of large organizations. Obviously, Facebook have some of it in there, I expect. There's obviously Alibaba, right? So I love Alibaba. Before the pandemic, I used to spend in the 650,000 miles I would spend on planes every year. I always made sure that I got myself over to Hangzhou, China, which is just a couple hours train rides away from Shanghai. And when I spent you know, a few days a week every year for the last 8 years now in Hangzhou, hanging out with my friends at Alibaba. And over in Alibaba, they're always using Spring. Everything's Spring. In 2014, I went to them and said, my friends, you have to see what we're doing. We've got this thing called Spring Boot. It's going to be huge. You gotta let me show you. And of course that took off. And then I went over there and said, we're doing this thing called Spring Cloud. And of course, then that took off. And then more recently, it's been Reactive, and then that took off. And then at some point, one of them came over here to the United States, and it was in my home. And I was like, oh, while we're here, I got to show you this thing called RSocket that, you know, that's cooking. They loved it, right? And so now RSocket is this big thing inside the organization as well. That is really promising, friends. These are large organizations that, you know, that use Spring and that use Reactive and that use RSocket. These are organizations that have the money, the wherewithal, the need, and the motivation to solve these problems themselves, and they still choose to build on the Spring ecosystem and to build on all that we're doing as in the open source, because it allows them to build better software faster, to get to production faster and safer. And at the end of the day, my friends, that's all that matters. Thank you so much for your time. I hope you're well. I hope you have a wonderful day, and I'm happy to answer questions now.